Hello everyone, welcome to Brain Blitz Audios. Today in this episode of NEET/JEE-Main, we're going to be looking at previous year questions of chemistry asked in medical and engineering entrance exams in India. Today we're dealing with another important unit in chemistry. The name of this unit is Atomic Structure, Chemical Bonding, and Molecular Structure. This is similar to the fourth chapter in the grade 11 syllabus for chemistry in CBSE. The name of that chapter is Chemical Bonding and Molecular Structure. So today we have a set of 5 questions and we will be running through them with some detail so that you can understand how to solve these types of questions. So let's come over to our first question. In which of the following species is the underlying carbon having sp3 hybridization? So the options are given: an alcohol, a carboxylic acid, an acetic anhydride. This is a ketone, and then there is an alkene. So how do we solve this question asked in 2002? First thing we need to know is we need to find out what sp3 hybridization is. So sp3 hybridization is basically having the electrons in the s in one orbital of the s suborbit and 3 orbitals of the p suborbit. So that is what you mean by sp3 hybridization, and this usually occurs when you have a single bond with that carbon. So when that carbon has one bond with another carbon or another element, then it has sp3 hybridization. Otherwise it doesn't. So in option A we have acetic acid, and they're showing the carbon that is attached to the oxygen. So acetic acid, that is CH3, and then you have C, then you have double bond O and OH. So as you can see, there is a double bond which is present here. So that means that that carbon is not having sp3 hybridization, so option A is incorrect. A similar story goes for option C, the ketone. This is basically acetone. Again, acetone has a C double bond O, then which is attached to CH3 and CH3. So therefore that carbon is again not sp3 hybridized, so option C is incorrect. If you look at option D is propene, and you can see in propene it's with the carbon that has the double bond that it gets underlined, so therefore it does not have sp3 hybridization, so option D is incorrect. The correct answer is option B, ethanol. So in ethanol you have CH3, CH2, OH. So as you can see, the carbon, that is the second carbon, it has single bond with all other elements, so therefore option B is the correct option for this question asked in 2002. Next question. The number of sigma bonds in P4O10 is it 6, is it 7, is it 17, is it 16? So so what are exactly sigma bonds? Sigma bonds are bonds formed by overlapping of the s orbitals, and these are the strongest type of bonds, so therefore having these bonds is very important. So the rule about sigma bond is that if you have a single bond, then it's always a sigma bond. For multiple bonds, such as double or triple bond, there will be 1 sigma plus X number of pi bonds. So in order to understand how many sigma bonds are present in P4O10, it is a good idea to draw the structure for P4O10. So to draw the structure of P4O10, we have 2 phosphors connected by oxygen in the middle, and then they are connected upwards by oxygen and also towards the plane by oxygen. Then there is a double bond with another oxygen to the side, and then you have a phosphorus in between these oxygens, and then it is connected to another oxygen, which is connected to a phosphorus like this. These two oxygens bond up with that, and then there's a double bond for that phosphorus as well. Another double bond at the bottom as well. So this is the correct structure for P4O10. I know it's a little bit untidy, but this is as close as you can get. So as you can see, there are 4 double bonds, and then you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 single bonds. So you have 12 times sigma plus 4 times sigma plus, since it's a double bond, so you have 1 pi. So you have 12 sigma plus 4 sigma plus 4 pi. So the number of bonds are 16 sigma plus 4 pi. So you have 16 sigma bonds present in P4O10. So option D, 16, is the correct option. Now, let's look at this question. In a hydrogen atom, if the energy of an electron in ground state is 13.6 electron volts, then the energy of its second excited state is 1.51, 3.4, 6.04, 13.6. So, how do we find out the energy of the second excited state? We need to find out what exactly is the second excited state. Ground state refers to an electron at the orbit n equals 1. So that means the second excited state would mean n is equal to 1 plus 2, so that means n equals 3. So an electron in the third orbit will be in its second excited state. So how do we find out the energy in the third orbital? Energy in nth orbital is given as 13.6 divided by n squared electron volts. So the energy for the third orbital, the third orbit, will be 13.6 divided by 3 squared. So that is 13.6 divided by 9. Let's do the division. So that is 136 divided by 9. So when you take 13, that's 1. 9 gives you 4. Then there's 46. So that's 5. 45 gives you 1 point. And then there's 0. So 9 goes into 10 one times. And then there's a 1. And then there's, then there's a 9. And then there's a 1. So it goes on and on. So you have 15.1 bar as your quotient. But since we are dividing 13.6, that becomes 1.51. So the correct answer is option A, 1.51 electron volts. So option A is the correct option. By using the correct formula, energy in the n state is equal to 13.6 divided by n squared. Now the value of n, you have to be careful with that. If you're talking about first excited state, then the n value will be 1 plus 1, so that is n equals 2. So you always need to remember that n equals 1 is the ground state. If you're talking about second, third, or fourth excited state, add 1 to that number given, and you'll get the value for n. So in this case, 2 plus 1 gives you 3. Now let's look at this question. A square planar complex is formed by hybridization of which atomic orbitals? So let's look at the hybridization of a square planar complex. A square planar complex is given by the hybridization dsp2. So that means you have an s orbital, and since you have 2 p orbitals, then that will be px and py. Because in the order of p orbitals, px is less than py in terms of energy. Now, the d orbital comes before the s orbital, so that means this d orbital will be the last d orbital of the previous shell. So that means if you take the series of d, then the series of d is dxy, dyz, dzx, and then you have dz square, then you have d of x square minus y square. So this d has to be dx square minus y square. So therefore, if you're looking at the given options, you can see that option B is the correct answer to this question. Option A is almost correct, but dyz is incorrect. And then in option C, again, dz square is shown, so that's incorrect. In option D, the p orbitals are also marked wrong, so option D is incorrect. The right answer is option B, s, px, py, and dx square minus y square. That is the correct answer for this question asked in 2002. Now we come to the final question of this episode, again asked in 2002. The uncertainty in position of a minute particle of mass 25 grams in space is 10 raised to minus 5 meters. What is the uncertainty in its velocity? So, for those of you who are getting stumped, this question is based on Heisenberg's uncertainty principle. Uncertainty principle. And if you were to write the formula for that, then it is delta x times m delta v equals h by 4 pi. I mean, basically less than equal to h by 4 pi. So what this means is that the uncertainty in position and the uncertainty in velocity is their product with mass. I mean, the uncertainty in position and the uncertainty in momentum, their product is less than or equal to the value of h by 4 pi, where h is Planck's constant. Its value is given. So momentum can be written as m times delta v. So now we know the uncertainty in position, we know the mass, we know h, we know pi. We just need to find the uncertainty in velocity. So if you were to actually solve this question, then you would rewrite the formula as delta v equals h divided by 4 pi m delta x. Now the reason why we're writing equal to is we're finding the best possible scenario, that is when at delta x times delta p is equal to h by 4 pi. So that is the maximum case scenario. So anything lesser than that also works. So moving on, let's apply the values. The value of h is 6.6 into 10 raised to minus 34 divided by 4 times 3.14 times 25 grams. So that means into 10 raised to minus 3 times 10 raised to minus 5. So 25 times 4 gives you 100. 100 times 3.14 gives you 314. So it is 6.6 divided by 314 into 10 raised to minus 34 plus 3 plus 5. Now, using 6.6 will be a problem, so we can just, multiply by 100. So that is 660 divided by 314 into 100. So that 100 we can write as 10 raised to minus 2. So it'll be basically 10 raised to minus 34 minus 2 plus 3 plus 5. So 34 plus 2 is 36. 36 minus 8 is 28. So you have 660 divided by 314 into 10 raised to minus 28 meters per second. Now we need to find the value of 660 divided by 314. Fortunately, we have space for division. 660 divided by 314. 314 times 2 gives you 628. So 10 minus 8 is 2. 5 minus 2 is 3. 0. So then you have to put point and then write a 0. So 314 times 1 is 314. That gives you 6. And if you were to write 0 again, so you get 100. So then 2.101, and it goes on and on. So in approximate, you can write an answer of delta V as 2.1 into 10 raised to minus 28 meters per second. And if you were to look at our options, you can see that option C is the closest to our correct answer, which is in fact the correct answer. So therefore, option C is the correct option for this question asked in 2002. So that concludes this episode of NEET JEE-Main. We hope you found this episode interesting. For more useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. So until the next webisode, take care, stay safe, bye-bye for now.